Bright Tuty. Every student matters.
Sides of a triangle are given below. Determine which of them are right triangles. In case of a right triangle, write the length of its hypotenuse. So, which triangle will be a right triangle if, let us say, three sides are given and sum of squares of any two sides is equal to the square of third side, then we will say it is a right angle triangle, and the biggest side will be the hypotenuse. Okay. So, first case here is 7, 24 and 25 in centimeters. Okay. So, I will square these and then check. 7 squared is 49, 24 square is 576, 25 square is 625. Right. Now, if I add these two, is it equal to this? Let us see. 49 plus 576 is equal to 625. So, yes, 7 square plus 24 square is equal to 25 square. That means 7, 24 and 25 are the units that satisfy Pythagoras theorem. So, they are known as Pythagorean triplets. These are Pythagorean triplets, right, and the biggest side here is 25. So, it is the hypotenuse. So, yes, it is a right triangle. Yes, it is a right triangle with hypotenuse equal to 25 centimeter. Okay. Similarly, you can check the next one. 3 square is 9, 8 square is 64, 6 square is 36. So, if I add these two, I won't get this, right. So, you just have to add the smaller sides, okay, and see whether their sum of squares become the square of the biggest side. So, in this case 9 plus 36 is obviously not equal to 64. So, it is not a right triangle. Look for the next one, third part. 50, 80, 100. 50 squared is 2500, 80 squared is 6400, 100 square is 10,000. So, sum of 2500 and 6400 is not equal to 10,000. So, it is not a right triangle. Look for the fourth part. 13, 12, 5. So, if some of you know about Pythagorean triplets, they can easily identify that these are Pythagorean triplets. Let me tell you why. Because if you square 13, it will give you 169. Square of 12 will give you 144, right, and square of 5 is 25. Now, if you add these 144 and 25, you will get 169. So, I can say 13 square is equal to 12 square plus 5 square. Hence, it is a right triangle and hypotenuse is equal to 13 centimeter. Okay. Now, the next one. We have done ample number of questions of this type. So, it will be very easy for you. PQR is a right triangle, right angled at P. Let me draw the diagram first. PQR is a triangle right angled at P. So, let it be P, this be Q and this is R, and M is a point on QR such that PM is perpendicular to QR. Okay. So, this is 90, this is 90. PM square equal to QM into MR. So, I require PM square, this QM into MR. So, how can I obtain this? If I consider these two triangles only, okay, let me see. If this angle is alpha, what will be this angle? This angle will be 90 minus alpha. This is alpha, this is 90. So, this angle will be 90 minus alpha, right, and this is 90, this is 90 minus alpha. So, this angle will be alpha. Why? Because to satisfy the angle sum property of a triangle. Now, triangle QMP is similar to triangle. See, QMP means alpha 90, 90 minus alpha. So, here alpha 90, 90 minus alpha means PMR. So I have checked the correspondence also. Now I need to create PM square. So PM by MR is equal to QM by PM. Why? Because the ratio of corresponding sides is equal in case of two similar triangles. So I am just taking the corresponding sides. So I have taken PM, and from here I have taken MR. From here I have taken QM, and from here I have taken PM. So these are the corresponding sides. Now if I cross multiply, PM square is nothing but QM into MR, and it is the proof. Okay. Now ABD is a triangle right angled at A. AC is perpendicular to BD. So what is the figure like? It is like this. There is this right angle triangle, right angled at A, right, and other two vertices are A, B and D. Now AC is perpendicular to BD. That means we will drop a perpendicular like this, which is AC. Show that AB square is equal to BC into BD. So the fact that I am going to use here is, we have discussed it a lot of times, that this smaller triangle is similar to the bigger one. This smaller triangle is also similar to the bigger one, and these two triangles are similar to each other because their angles are equal. So by angle similarity, we can easily prove that these triangles are similar. Hence their ratio of corresponding sides is also equal. So that is what we will use to prove these. Okay, so let us first of all again prove that these triangles are similar. So if this angle is alpha, what can I say about this angle here? This will be 90 minus alpha, because this angle is 90, right? And angle A is 90. So if this part is 90 minus alpha, the remaining angle will be alpha, so that this angle A becomes 90. Now this is 90 and this is alpha, so this angle here is 90 minus alpha. Why do I say so? Because if you add these three angles, you will get 180 degrees. Okay. Now see, triangle ABC is similar to, when I say ABC, let us trace the angles. 90 minus alpha, alpha 90. So it will be similar to 90 minus alpha, alpha 90. So DAC. And these will be similar to 90 minus alpha, alpha 90. So DBA. Right. ABC, I go from 90 minus alpha to alpha, then 90. In DAC, I go from 90 minus alpha, alpha, then 90. And in bigger one, that is DBA, I go from 90 minus alpha, alpha, and then come to 90 degrees. So yes, the correspondence is correct. Now we will use this relation or this similarity to prove these three results. First, I require AB square, BC and BD. So let me use, where will I get AB square? I have got AB here, I have got AB in this one. So let me use this and this. So AB by DB is equal to BC by AB. It is very easy to know which correspondence to use, because I need to create AB square. So I will use this triangle and this triangle. In both these triangles, AB is common, right? And which ratio I will use? I will use the ratio involving AB. So AB, if I take from here, I will have to take DB from here, which is the corresponding side. And now I need another AB, which can be taken from here. So I need to take BC from here. Now AB square is equal to BC into BD or DB. So first part is proved. For second part, I need AC square and BC into DC. So AC is common in these two triangles, because I need to create AC square. So I will use ABC and DAC. So triangle ABC is similar to triangle DAC. Now I require AC square. So I just know that I'll use this AC. So, I'll have to divide by this corresponding side DC, and it will be equal to, now I need this AC. So, I need BC from here. So, BC by AC, hence AC square is equal to BC into DC. So, second part is also proved, right. Now, for the third part, AD square I require. Okay. Where do you see AD? I see AD in this one and in this one. So, I will use this similarity, that triangle DAC is similar to triangle DBA, and I require AD square. So, AD from this, then DB from this, or BD from this will be equal to AD from here. So, I will have to take CD from here. So, CD by AD. Okay. This means AD square is equal to BD into CD. So, the third part is also proved, right. Okay. Now, ABC is an isosceles triangle right angled at C. So, let us say this is a triangle ABC and this is the right angle, and it is an isosceles triangle. Now, if it is an isosceles triangle, then AC will be equal to BC. Why? Because there cannot be other 90 degrees, right. This has to be the biggest side. So, the smaller sides will be equal. So, AC is equal to CB. Now, I need to prove AC square is equal to twice of AC square. So, I can say AC equal to CB sides of isosceles triangle, or we can say equal sides of isosceles triangle, right. So, AC is equal to CB. Now, applying Pythagoras theorem, I can say AB square, that is hypotenuse square, is equal to AC square plus CB square, right. Now, I can replace CB by AC. So, AC square plus AC square, hence twice of AC square, right. And you can also replace AC by CB if the question requires. So, you can also say twice of CB square. AB square is also equal to twice of CB square, because AC and CB can be used interchangeably because they are equal, right. So, the biggest side in a right angle triangle is hypotenuse, and if the triangle is isosceles, then smaller sides will be equal to each other. Okay. In other words, you can also say that these angles have to be equal. These angles have to be equal, and sum of these angles is 90 degrees. So, they will be 45 degrees each, and their sides opposite to these angles will be equal. I hope this is clear to you. Now, in this question, ABC is an isosceles triangle with AC equal to BC. So, let us make a triangle here such that AC is equal to BC, that is, this side is equal to this side, and AB square is given equal to twice of AC square, and we need to prove that this is a right angle triangle. So, if we can satisfy Pythagoras theorem in this triangle, then we will say this is definitely a right angle triangle. And how do we do that? We will just use AC equal to BC to prove that, because 2AC square can be written as AC square plus AC square, and let us replace one of these ACs by BC. So, it will be equal to AC square plus BC square. Now, square of a side is equal to sum of squares of other two sides. That means, triangle ABC is a right triangle with AB as its hypotenuse and angle C as right angle. Okay. ABC is an equilateral triangle of side 2A. Find each of its altitudes. Now, if side is equilateral, then all sides are equal and they are equal to 2A. So, their altitudes will also be equal. So, if you can find one of the altitudes, all the altitudes are going to be the same length altitudes. Now, this is an equilateral triangle. So, in equilateral triangle, let us say this is ABC. If I drop a perpendicular from any of the vertices to the opposite side, what will happen is, now this is altitude AD. Similarly, you could have dropped a perpendicular from B to AC, and that is also an altitude which will be of the same length. Now, see, if AD is altitude, in equilateral triangles, what happens is these two triangles are congruent to each other. Why? Because this altitude divides this side BC in two equal parts, because altitude in equilateral triangle is also the median, right. So, this BD is equal to DC and these are equal to A units each, half of BC, right. If you know this much, then it is very easy to apply Pythagoras theorem in one of these triangles. Let us apply Pythagoras theorem in this triangle. AD square will be equal to AB square minus BD square. AD square is square of its altitude, right. AB square means 2A squared, BD squared is A squared. So, this is 4A square minus A square, that is 3A square. So, AD or length of altitude will be equal to root 3 into A. Okay. And you can use this as a general expression also, that length of altitude is equal to root 3 by 2 of its side in case of an equilateral triangle. Side here was 2A. So, if you take 2A and multiply it with root 3 by 2, then it will give you root 3 into A, which is nothing but the altitude. Okay. Similarly, if you drop a perpendicular here, these segments will be A units each. And now, if you apply Pythagoras theorem in any of these two triangles, you apply Pythagoras theorem here, then you will get the altitude, let us say BE, and it will be of the same length root 3A. Okay, you can verify it yourself. Now, one thing, if somebody thinks that in case of equilateral triangles, when I drop a perpendicular, this we have discussed in class 9th, and it should be clear to you by now. If you drop a perpendicular here, see, this side is equal to this side, right. Let us say this is 2A. So, this will also be 2A, right, and this is a common side in both these triangles, and this angle is 90 degrees and this is also 90 degrees. So, by RHS congruence criterion, these two triangles are congruent to each other, hence their corresponding parts are equal. So, this segment here is equal to this segment by CPCT. So, you can always say that when you drop a perpendicular in a in an equilateral triangle from any of its vertices, it will act as median also for the other side, or it will divide the other side in two equal parts. Prove that the sum of squares of sides of a rhombus is equal to sum of squares of its diagonals. So, in case of a rhombus, where do I have a 90 degrees angle? In case of rhombus, all four sides are equal and its diagonals are inclined at 90 degrees to each other. So, if this side is A, this side is also A, this is A, this is also A. I have written this A just to help you to visualize this clearly, that this is a rhombus with all sides equal and its diagonal cut each other or intersect each other at 90 degrees. Now, I need sum of squares of the sides, that means AB square plus BC square plus CD square plus AD square, and I need to show it equal to sum of squares of its diagonals, that is AC square plus BD square. Now, notice two things. Number one, all sides are equal. So, if I can write it as 4A square also, This is number one thing. Second thing, rhombus is also a parallelogram, right? It's a special kind of parallelogram where all four sides are equal. Okay. So, rhombus is a parallelogram. So, rhombus is a parallelogram. So, its diagonals bisect each other. Okay. If you take care of these two things, then this question is pretty easy. So, you just apply Pythagoras theorem in this triangle. Let us name this point as M. So, in triangle ABM, AB is hypotenuse. So, by Pythagoras theorem, I will say AB square is equal to AM square plus BM square. Right. Now, AM is just half of AC. So, I will write it as AC by 2 squared. BM is half of BD. BM is half of BD. So, I will write it as BD by 2 whole square. Why is it half of? Because it is a parallelogram and its diagonals bisect each other. So, this is BM is half of BD, right. So, it can be written as AC square by 4 plus BD square by 4, and it is equal to AB square. So, if I apply both sides by 4, the 4 AB square will be equal to AC square plus BD square. So, I have obtained the right hand side of the desired proof, but left hand side is still not visible. But if you clearly see that 4 AB square is there, and AB is equal to AD is equal to CD is equal to BC, because it is a rhombus. So, I can write it as AB square plus AB square plus AB square plus AB square, and it is equal to AC square plus BD square. Now, I will replace this by AD and CD and BC. So, AB square plus, let us replace this by BC, this by CD square plus this by DA square. So, it is equal to AC square plus BD square. Hence, I can say sum of squares of all the sides of a rhombus is equal to sum of squares of its diagonals. Okay. So, it was an easy question which we could prove using just one triangle here, and the properties of rhombus being a parallelogram and that the sides of a rhombus are equal. In this figure, O is point in interior of a triangle ABC, and OD, OF, OE are perpendiculars dropped on these sides. Show that OA square plus OB square plus OC square minus these is equal to this. So, let me focus on OA square, OB square and OC square first. Okay. In triangle AOF, this angle is 90. So, AO square is equal to AF square plus OF squared, right, by Pythagoras theorem. Now, OB square. So, in this triangle here, OB square is equal to OD square plus BD square, right. And third thing I require is OC square. So, OC square in this triangle, let us say, is OE square plus EC square. Okay. Now, if I add these three, then AO square plus OB square plus OC square will be equal to AF square plus OF square plus OD square plus BD square plus OE square plus EC square. Why did I write these? By Pythagoras theorem. Okay, because this exercise is based on Pythagoras theorem, so I have mentioned this here. Now, I require minus D square minus OE minus OF minus OD, OE and OF. So, I will bring them on the left hand side. So, AO square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square or EC square, right? So first part is proved. Look at the second one, AF square plus BD square plus CE square. So AF square will be this segment, BD square is this segment, and CE square is this segment, and their sum is equal to AE square plus CD square plus BF square. AF square, BD square and CE square are there in the first part's proof also. So we will need to convert this side into this, that is AE square plus CD square plus BF square. So let us look at AE square. Where is AE in this triangle? AE square by Pythagoras theorem is OA square minus OE square. So can we find OA square minus OE square? Yes. So let us write this separately, OA square minus OE square. See, I am rewriting this expression. On the left hand side, I am clubbing some of the terms. I have clubbed OA square minus OE square, and why do I do that? Just to create AE square. So to create CD square, I will need OC square minus OD square. So OC square minus OD square. Let me club these. And for the BF square, I will require the remaining terms, that is OB square minus OF square, and it is equal to AF square plus BD square plus CE square as per the proof above. So I have just written this expression in these terms, right? This is this exactly same expression as this. I have just changed the order of some terms just to create these. Now we can see by Pythagoras theorem, OA square minus OE square is AE square, OC square minus OD square is CD square, OB square minus OF square is BF square. You can check OB square minus OF square. OB square minus OF square is BF square by Pythagoras theorem. So it is equal to AF square plus BD square plus CE square. Hence proved. Now once you say that this is equal to this, you can mention the name of triangle also. If the question is of, let us say, 6 marks, you need to explain each and every step. Then you explain that why did you write OA square minus OE square as AE square. I have told you verbally, but you write that in triangle OAE, by applying Pythagoras theorem, you can say OA square minus OE square is equal to AE square. So these kind of statements should be written by you to explain the steps that you are taking. Now in the next question, a ladder 10 meter long reaches a window 8 meter above the ground. So it is 8 meter and there is this window, and there is a ladder 10 meter long which reaches this window. So this ladder is 10 meter long and this is 90 degrees, right? Because when we say a wall or there is a window on a wall, we always take the angle 90 degrees between the ground and wall. Find the distance of foot of the ladder from the base of the wall. So this is the base of the wall, this is the foot of the ladder. So we need this distance basically. So if this is A, B, C, we require BC. So by Pythagoras theorem, hypotenuse square, that is AC square, is equal to AB square plus BC square in this triangle, right? So 10 square is equal to 8 square plus BC square. Hence BC square is equal to 100 minus 64, that is 36. So this implies BC will be equal to root of 36, that is 6 meter. And you can memorize these 6, 8, 10 as Pythagorean triplets. So if in a right angle triangle you are given two sides as 8 and 10, then the third side will be 6 if 90 degrees is opposite 10, right? So 6, 8, 10 are Pythagorean triplets. a guy wire attached to a vertical pole of height 18 meter is 24 meter long. So there is this vertical pole of 18 meter which is 24 meter long. The wire is 24 meter long and has a stake attached to other end. How far from the base of pole should the stake be driven so that the wire will be taut? That means this wire, when completely stretched, or in other words its taut, is 24 meter long. So we need to find this distance here. So if this is A, B, C and this angle is 90 degrees, we need to find BC in this question. Okay. So by Pythagoras theorem, AC square is equal to AB square plus BC square. Why? AC square is hypotenuse. So hypotenuse square is equal to sum of squares of other two sides. So 24 square is equal to 18 square plus BC square. Now BC square can be written as 24 square minus 18 square. It is recommended that you remember or you memorize the squares up to 25. Even if you don't, then in these questions you always try to take some things common that you can take. So in these two I can take 6 square as common. From here I will have 4 square and from here I will have 3 square. You can check it yourself. So 6 squared is into 4 square is 16 minus 9, that is 7, and it is equal to BC square. So BC square is equal to 6 square into 7, hence BC is equal to 6 into root 7 meter, and this is your answer, right? So an aeroplane leaves an airport, flies due north at a speed of 1000 km per hour. So let us say this is north, this is south, this is west and this is east. An aeroplane leaves an airport, flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport, let us say this point is the airport, and flies due west at a speed of 1200 km per hour. So how far apart will they be after 1.5 hours? So in 1.5 hours, how far will it go? At a speed of 1000 km per hour, in 3/2 hours, the plane will go 3/2 into 1000 kilometers, that is 1500 kilometers. So the plane which travels due north will go to 1500 kilometers distance, right, at this place, which is 1500 kilometers away from the airport. And the other plane which is traveling at a speed of 1200 km per hour, in 3/2 hours or 1.5 hours, it will travel 3/2 into 1200, that is 1800 kilometers, right? The plane traveling due west, this was traveling due north. Okay, so this plane will reach somewhere here, this place, which is 1800 kilometers away from the airport. Now I need to find this distance. Okay, let us name this A, B, O. O is the airport. See, to find AB, I know that this angle is 90 degrees, right, because these are the directions north, south, west, east, and these are mutually perpendicular. So this angle is 90 degrees. So in triangle OBN, BN being the hypotenuse, I will say BN square is equal to OA square plus OB square, right? What is OA square? It is 1500 square. And what is OB square? It is 1800 square. So I always recommend that you take common whatever you can. So from these two, let us take 300 square as common. So I'll have 5 squared from this and 6 square from here, right? Now Bn square. So Bn, or the required distance, will be square root of this expression, which is 300. 300 squares, square root will give me 300, and square root of 6 square plus 5 square is nothing but, this is 36, this is 25. 36 and 25 will give me 61. So root 61 is there, and this distance is in kilometers. 300 root 61 kilometers. So this will be the distance between two planes after 1.5 hours. Okay. Let's move to the next one. Two poles of height 6 meter and 11 meter stand on a plane ground. If the distance between feet of the poles is 12 meter, find the distance between their tops. So I have got two poles, one is 6 meter and another one it is 11 meter, right? They stand on a plane ground. Distance between the feet of poles, that is this distance, is 12 meter, right? So I need to find distance between their tops, that is this distance. So if I draw a line parallel to this, it will also be 12 meter, right? Because these poles are parallel to each other, they stand on a plane. So these angles are 90 degrees, hence this angle will also be 90 degrees. So what will be this length here? This length will be 11 minus 6, that is 5 meter. Now if you have listened to my lectures carefully, 5, 12, then what will be this length? This will be 13 meter, because this is Pythagorean triplets. Otherwise you take these as A, B, C, D, E. Then you say BC will be equal to ED, because I have taken them parallel. So equal to 12 meter. Now AC will be equal to AD minus CD. CD is nothing but BE. So 11 minus 6, 5 meter. Now in this triangle ABC, applying Pythagoras theorem, I can say AB square is equal to AC square plus BC square. So 5 square plus 12 square, this is 25, this is 144, and the result is 169. So AB is square root of 169, that is 13, and the unit is meter. Okay, so the distance between top of the poles is 13 meter. Now D and E are points on the sides CA and CB respectively of a triangle ABC, right angled at C. So this is a right angle. D and E. D is a point on CA. Okay. So let us take D here, and E on CB. Let us take a point E here. Okay. Prove that AE square plus BD square. So let us join AB and let us join BD. Okay. First of all, let us see what is AE square. So this is a right angle. So by Pythagoras theorem, I can say AC square plus CE square will be equal to AE square. And how do I obtain BD square? BD square is equal to, Pythagoras theorem says it is equal to DC square plus BC square. Now their sum, AE square plus BD square is equal to AC square plus CE square plus DC square plus BC square. But I require AB square here. What is AB square? AB square is nothing but AC square plus BC square. So do I have that? Yes, AC square plus BC square. So it is equal to AB square. Again, by Pythagoras theorem, you can mention the triangle which you are referring to. Now CE square plus DC square. What is CE? Here is CE. and where is DC square? CE square plus DC square. So, this is CE, this is DC, and if I join D with E, this will be the hypotenuse in this triangle. So, CE square plus DC square is equal to DE square in triangle DEC, which is the right hand side, hence proved. Okay. The perpendicular from A on side BC of triangle ABC intersects BC at D. So, let us say we have got this triangle. ABC, and this is perpendicular AD, right. So, DB is thrice of CD. So, this DB, if CD is, let us say, x, then BD is thrice of CD, that is 3x, right. Prove that 2AB square is equal to 2AC square plus BC square. All right. So, I require AB square first. AB square is equal to, in this triangle, AD square plus DB square. Why? Because by Pythagoras theorem, in triangle ABD, right. So, AB square is equal to AD square plus DB square. Now, tell me what is AC square? AC square is equal to AD square plus CD square, right. Now, you can say that BD is 3x, CD is x. So, what will be BC? It will be 4x, right. So, if I have to convert this BD into BC, so BD and BC, what will be the relation between BD and BC? It will be 3 by 4. Right, the ratio between BD and BC is 3 by 4. So, BD is nothing but 3 by 4th of BC. Okay. And if I want a relation or a ratio between BD and CD, I can say BD by CD is equal to 3 by 1 or BD is equal to 3 CD, right. BD is equal to 3 CD can be used, and BD equal to 3 by 4 BC can be used. And what is the relation between CD and BC? CD is equal to BC by 4. So, BC can be replaced by 4 CD also. Okay. So, let us use this relation. What can we say about these two equations? If I take AD square in both of these, AD square is equal to AB square minus BD square in the first one, and it is equal to AD square minus, it is equal to AC square minus CD square here. So, if I equate these, AB square minus BD square is equal to AC square minus CD square, right. So, AB square is equal to BD square minus CD square plus AC square. Now, what is BD and CD? See, in this expression I require AB, AC and BC. So, I need to convert these into BC. How do I do that? I know BD is equal to 3 by 4 BC. So, 3 by 4 BC whole square minus CD is equal to 1 by 4 BC. So, 1 by 4 BC whole square plus AC squared. So, 3 by 4 minus 1 by 4, 3 by 4 means 9 by 16 BC square, and this is 1 by 16 BC square plus AC square. Now, 9 by 16 minus 1 by 16 is 8 by 16, that is 1 by 2. So, 1 by 2 BC square plus AC square is equal to AB square. Now, you multiply both sides by 2. So, you will get 2 AB square is equal to 2 AC square plus BC square, and this is what we had to prove here. Okay. In an equilateral triangle ABC, D is a point on BC such that BD is 1/3 of BC. That means, let us say this is the equilateral triangle ABC, and D is a point, let us say here, such that it is 1/3 of BC. So, if BC is, let us say 3x, it is x. BC is 3x, let us say. Then this is x. It is 1/3 of BC. Now, we need to prove 9 AD square is equal to 7 AB square. Let us join AD. Okay. And this is an equilateral triangle. So, these angles are 60 degrees each. Okay. Now, I require AD square and AB square. So, let me drop a perpendicular here. I know in case of an equilateral triangle, if I drop a perpendicular from a vertex to the other side, it bisects the other side. So, I have taken this complete side BC as 3x. So, what will be this segment here? It will be 3x by 2. And what will be this segment? BM, it will also be 3x by 2. So, what will be DM? I am doing this just to make this question very clear to you. So, it will be 3x minus 2x, that is x by 2. So, this portion is x by 2, right. I may or may not require these portions, but let us start with that. Now, once I know this much information, I just need a relation between AD and AB. So, if I can obtain AD square in terms of x and AB square in terms of x, then I will compare these two. So, AD square is equal to AM square plus MD square, right. Why? By Pythagoras theorem in triangle ADM. So, what is AM? AM is just the height of an equilateral triangle with side 3x. So, it is equal to root 3 by 2 into side, that is 3x, right. So, it is equal to 3 root 3 x by 2. Okay. So, now see, AD square is equal to AM square, which is 3 root 3 x by 2 squared plus MD square. MD square is x by 2 whole square. So, AD square will be equal to, this is 9 into 3, 27 by 4 x square plus this is x square by 4. So, 27 by 4 x square plus x square by 4 is 28 by 4 x square, that is 7 x square, right. Now, other thing I need is AB square. So, AB square is equal to, AB square is equal to AM square plus BM square. So, AM square plus BM square. What is AM square? AM square we already know is 27 by 4 x square, right, because AM is 3 root 3 x by 2 plus BM square. What is BM? BM is half of BC. BM is half of BC, hence it is equal to 3x by 2. So, square it. Now, it is 27 by 4 x square plus 9 by 4 x square. So, 36 by 4 x square, hence 9 x square. Now, compare AB square and AD square. AB square and AD square. So, AB square by AD square, let us say, is equal to 9x square by 7x square. So, from this x square can be cancelled and 7 AB square will be equal to 9 AD square, right. So, we have used two properties of equilateral triangle, that its altitude is equal to root 3 by 2 of side. This we have obtained using Pythagoras theorem in previous question. So, I used that fact because in an equilateral triangle, if this is A, then if you drop a perpendicular, this will be A by 2. So, to obtain this height, I can say A square minus A square by 4. square root using Pythagoras theorem. So it will be equal to root 3 by 2 of side. Okay. So I used that property, and also I used that if you drop a perpendicular in an equilateral triangle, it bisects the side. Okay. All right. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitudes. So if it is A, B, C, and let us say this is one of its altitude D, 3 times the square of one side, that is 3AB square, let us say, is equal to 4 times square of one of its altitude, 4AD square. This is what we need to prove. Now again, if you know the basic properties of equilateral triangle, that if AD is perpendicular to BC, it will bisect BC, right. So let us say all sides are A each in this equilateral triangle. So BD will be A by 2, and this will also be A by 2. Now by applying Pythagoras theorem here, I can say AB square is equal to AD square plus BD square, right. So ADB square is A square, AD square we have to obtain, BD square is A square by 4. So AD square will be equal to A square minus A square by 4, that is 3A square by 4. Hence AD is equal to root 3 by 2 A. So this side is root 3 by 2 A, this length. Okay. Now what you can do is you can compare these AB and AD. So AB square is nothing but A square, AD square is nothing but root 3 by 2 A whole square, that is 3 by 4 A square. Okay. Now AB square by AD square can be written as A square by 3 by 4 A square. So A square will be cancelled and it will be 4 by 3. So 3 AB square is equal to 4 AD square. Okay. Some of you could have seen this result directly because you knew that the altitude or height in case of an equilateral triangle is root 3 by 2 A. So you could have directly seen this, that how that 3 by 4 AB square is equal to AD square, because AD is root 3 by 2 AB, side AB. Okay. Anyhow, so this question is done. Let us move to the next one. Tick the correct answer and justify that in triangle ABC, AB, AC and BC are given, then angle B is. So in case of a triangle and 3 sides are given, if sum of squares of any 2 sides is equal to the square of third side, then we will say it is a right angle triangle. Okay. So let us check their squares first. AB square is equal to 36 into 3, that is 108 centimeter. AC square is 12 square, that is 144 centimeter. BC square is 6 square, that is 36. So if you add AB square and BC square, it is equal to 108 plus 36, that is 144, which is nothing but AC square. So yes, AB, BC and AC satisfy the Pythagoras theorem. Hence ABC is a right angle triangle. Now this being the longest side is the hypotenuse. So AC is hypotenuse, and angle opposite to AC, that is angle B, is right angle, that is 90 degrees. So angle B is equal to 90 degrees. Okay. And if the students take care that the ratio here is 6 root 3, 12, 6. So if you notice the ratio is 1, 2 and root 3. Whenever you have a ratio like this, 1 is to root 3 is to 2, the angle of, first of all, this is about a triangle which is 30, 60, 90 triangle, right? That means one of the angles is going to be 90, 130, and one angle obviously be 60 degrees, and the side opposite to 90 degrees is going to be the biggest side, that is this one, okay, which in this case is AC. So, angle opposite to AC, that is angle B, is 90 degrees. I hope this chapter is clear to you. Okay, so this exercise is done. I hope this chapter is clear to you. In the next lecture, we will do some extra questions which are optional in from the point of view of your examination, but for conceptual clarity, we will still do those questions. I hope you have understood this chapter. Thank you.